హాయ్ హలో ఫ్రెండ్స్. వెల్కమ్ టు టీ అకాడమీ. ఈ వీడియోలో మనం ప్రీవియస్ అసిస్టెంట్ ఇంజనీర్ సంబంధించినటువంటి ఒక ఎగ్జామినేషన్ పేపర్లో ఉన్నటువంటి క్వశ్చన్స్ని సాల్వ్ చేయబోతున్నాం. సో ఇన్ దిస్ వీడియో ఐమ్ గోయింగ్ టు డిస్కస్ ద ప్రీవియస్ ఏఈ పేపర్ సొల్యూషన్స్ ఆఫ్ సబ్జెక్ట్ కంట్రోల్ సిస్టమ్స్ హియర్. Okay. All right. So we'll start the question here. Right. The question here it is: two unit feedback systems A and B with a open loop transfer function are given here. That is a G A of S is equal to 9 by S into S plus 1 and GB of S is equal to 16 by S into S plus 2. Which of the following statement is correct? So the options are here. System A has higher overshoot than system B. A has lower overshoot than B. A has lower settling time than B. Both have equal settling times here. So here we need to find the two parameters. That is, the first one is a overshoot and second one is a settling time. Okay, so the given system is a open loop transfer function. So first we will find the characteristics of this open loop transfer function. So we'll write the characteristic equation of, let's say this is a. Okay, so we'll write this as a 9. Okay, so plus s into s plus 1 is equal to 0. Okay, this is a characteristic equation, that is s square plus s plus 9. So this is the equation that is equal to 0 here. Okay, so when we compare the standard second order equation here, the equation will be s square plus 2 zeta omega n plus omega n square is equal to 0. So if you compare this equation, let me equation this is a 1, okay, and this will be 2, and comparing 1 and 2 here, what you'll get is omega n square is nothing but 9. From this, omega n is equal to 3, that is a radians per second, and we want the zeta value. So 2 zeta omega n is equal to what? 1. So here forgot to mention yes here. Okay, so from this, zeta value will be 1 by 2 zeta. Sorry, it's not zeta here. Let me correct, 2 omega n, right? So 1 by 2 into 3 is nothing but 6 here. We know that the overshoot, okay, so we can say overshoot here, overshoot is inversely proportional to zeta value. That implies it's nothing but 6 here. So peak overshoot, or we can say overshoot of A. So overshoot of A is proportional to, let's say, 6 here, having a higher value, right? And similarly, we'll check the cross check for the second, that is g of s, gb of s is equal to 16 by s into s plus 2 of a open loop transfer function. That is, now I'll write a characteristic equation of b, which is equal to, what is that? So 16 plus s into s plus 2 is equal to 0. So once you solve this equation, you'll get as a s square plus 2s plus 16 is equal to 0, and compare with the equation number 3 is compared with equation number 2. So between 3 and 2 here, okay, so between 3 and 2, what you can get here, it is omega n is nothing but 4, 2 zeta omega n s is equal to 2. So from this zeta value, what you can get here, it is 1 by 4. Now overshoot of the transfer function b is proportional to 4 here. So from this we can say the overshoot of A is greater than overshoot of B here. So from this, system A has higher overshoot than system B. So this is the answer from this derivation. Now I want to discuss about this settling time. So as the overshoot is more, so overshoot is inversely proportional to, proportional to settling time TS here. So that conclusion here it is, the system A is having more settling time than compared to second transfer function here. Okay, So from this conclusion, I can say that A will be the right answer here. Okay, so we'll move to the next question here. Now, next question here it is. The question here it is, right. This is the second question, friends. In this question, the gain margin of the system G of S is equal to 1 by S into S plus 1 into S plus 2 is given by. So there are two ways you can solve this problem. So generally I use the formula here. So what is the formula for the gain margin here? So let note down this gain margin formula. So gain margin is nothing but it is the maximum value of K for the stability. I'll write it down here. Maximum value of K, that's a gain for stability divided by it is the given value of K. Okay, so what is the default given value here? It is a K value, minimum value, or K default value is K minimum value is nothing but 1 here. Now I want to find the gain margin here. So to find the gain margin, first I will take the characteristic equation. Characteristic equation of this G of S is, so G of S is equal to, so S into S plus 1 into S plus 2. Okay, that is, so okay, right. So plus, let me take the K value here. Instead of taking 1 here, I'll take K here. Okay, so K is equal to 0 here. So S square plus S into S plus 2 plus K is equal to 0. So once you solve this equation here, simplification, S cube plus, we got 3S square plus 2S plus K is equal to 0. So by using the RH criteria, so we are going to find the value of K here. So to find the RH criteria here, I'm calling RH criteria, so that S cube, S square, S power 1 and S power 0 here. You can take it as these values here. Now if all the coefficients are positive here, then you can say the system is in stable condition. So from this, we'll take the first term 1 and 2 here. 1, 2, and remaining here it is a 3 and K here. Now what about the polynomial here? We'll get X. Let's assume X here. What is the value of X? X is nothing but 3 into 2 minus K into 1 divided by 3. So for the system to be stable, the X value should be greater than 0. Okay, that means what is the value? 6 minus K by 3 is equal to X here. X should be greater than or equal to 0 here. That implies what is the value you get here? Okay, substitute here means you will get the range of value is nothing but 0 less than K less than 6. So this is a maximum value. What about the K maximum value? Here it is nothing but 6 here. Substitute the value maximum value here. So maximum value of K for the system stability is nothing but here this value is a 6 and a given value of K is nothing but 1. So gain margin is nothing but 6 by 1 which is equal to 6 here. So answer is T. We'll move to the next question here. Okay, so okay, right. This is the transfer function y of s by v of s is equal to 1 by s cube plus 3s square plus 2s plus 10 is equal to 0 here. Is represented in the state variable form. The system matrix A is given by. So generally, we'll write this system matrix A in the form of identity matrix and all the coefficients here. So I'll write the basic transfer function here. So let me take a b here. B is nothing but a gain value here, c3 into s cube. Let me take here. I'll write in the form of c2. Okay, so that you can understand easily. C2 s square plus c1 s plus c naught here divided by s cube plus a2 s square plus a1 s plus a naught here. So comparing these two equations, okay, by comparing these two equations, what will be the matrix A here? So matrix A will be, okay, matrix A will be here. See, 0, 0, A naught, 1, 0, 0, 1, minus A naught, minus A1, minus A2 here. So compare these all the values here, comparison here. What you can get here is, what is the value of A naught here? Is nothing but minus 10. So A matrix will be equal to 0, 1, 0, 0, 0, 1. A naught means, by looking at the comparison, minus A naught means here minus A10, sorry, minus 10 here, and A1 will be minus 2, minus A2 will be minus 3. So this is the matrix A. So by looking the answer here, option D will be the correct choice for this question here. Okay, sorry, it's not the option D. Let me correct here. Sorry. Okay, so for this question, so answer will be B here. These are wrong. So answer B will be the right answer for this question here. Next question here. So this is a theory question here. Considering the following statements with respect to the time and frequency responses of a second order system. Peak overshoot is indicative of damping in the system. Next option is resonance peak depends upon the damping and natural frequency. And third one is resonance frequency depends upon only on the damping in the system. And the fourth point is resonance peak and resonance frequency can be used as a performance measure in the design of control system here. So before going to discuss the answer here, let me memorize the formulas here. What are the formulas that are asked here? The first formula that is asked is resonant peak. So resonant peak here, I'm talking about resonant peak. Resonant peak MR is equal to, so 1 by 2 zeta square root of 1 minus zeta square. So this is resonant peak value. So formula 1 here. And similarly, what's a peak overshoot? So this is a peak overshoot formula that I'm writing here. So MP, peak overshoot, is equal to exponential of, okay, minus zeta pi divided by square root of 1 minus zeta square. And the third one, that is resonance frequency. Omega R is equal to omega n, natural frequency of oscillations, into square root of 1 minus 2 zeta square. So these are the three formulas here. So now observe here, the peak overshoot is an indicator of damping in the system. So what is the resonant peak overshoot? Is the peak overshoot. So it indicates the damping in the system is, which is nothing but a true. So this one is a true option here. Okay, resonant peak depends upon the damping and natural frequency. See here, is any damping factor is there here, also here, but natural frequency is there? No. So it is false. Resonance frequency depends only on the damping in the system. See here, resonance frequency, it depends upon the damping as well as the natural frequency, but the given option here, it is depends only here. So only means it is also wrong option. And the final one, resonance peak and the resonance frequency can be used as a performance measures of the design of the control system. So this one is a true. So option 1 and 4 are the correct. So answer A will be the right option for this question here. I'll move to the next slide here. Okay, right. So this is a basic question that is asked here. The block diagram of a system is shown in the figure. The transfer function C of S R of S is given by. So you can use the Mason's gain formula to solve this network, or you can go for this signal flow graph technique. So both are really the same result here. So I'm going to use a Mason's gain formula here. As for the Mason's gain formula, what are the forward paths that we have here? So let me have forward path here. Only one forward path, that is 1 by S into 1 by S is nothing but 1 by S square. Now what are the individual loops here? So individual loops here, we have one loop, and here also we have second loop. So entire this part is nothing but second loop, right? First of all, L1 is nothing but minus 2 by s, and what about the L2? L2 is nothing but complete path here from here to here. Okay, that is a minus 1 by s into minus 1 by s. Sorry, 1 by s minus here term here. 1 by s into 1 by s is get minus 1 by square, 1 by square, right? Now, as per the Mason's gain formula, when signal flow graph here, what you can write here, it is a delta k and mk divided by delta here. So as per this Mason's gain formula here. Okay, so from this forward path is 1 by s square, only one forward path, so into 1 divided by, okay, now here 1 minus sum of individual loops here, so minus 2 by s minus 1 by s square. Okay, so once you're solving this, you'll get the answer as, so answer as 1 by s square plus 2s plus 1. So answer D will be the right answer for this question here. So next question here. So this is also a theory question here. So consider the following statements regarding the root locus of the system here. Okay. So here the breakaway points always occur on the negative real axis. Okay. So the breakaway points may occur, okay, anywhere in the S plane here. So this is a wrong, false statement here. A point on the real axis lies on the root locus if the total number of real poles and zeros to the right of the point is even. So it is not a even, it is a odd here. So this also wrong statement here. Next one, the number of branches of the root locus going to infinity is equal to the difference between the number of open loop poles and zeros. So this statement is a correct statement. And the last one, the value of k on the root locus can be determined by using magnitude criteria. Yes. So option 3 and 4 are the right options for this question here. So for this question, answer will be A here. So we'll move to the next question. So next question is from the Bordeaux plot diagram here. See this question. The asymptotic Bode plot of a g of s of a system g of s is shown in the figure is. So there is a shown figure here. Here we need to calculate the transfer function here. So transfer function we need to calculate here. So before going to discuss the transfer function here, so by looking at the diagram itself, what are the equation we can get here? So we can write the transfer function as we can written as. So see here, there is a origin, there is a pole at the origin here. So there is a one pole at the origin. So I will write this origin, there is a S here. Okay, one pole is there. Now after that pole at 2 at a omega equal to here, okay, so there is a 0 added to it. Okay, so that what I can do is I'll add 1 plus s by 2 here. I'm writing a standard form here and I'll take the gain as a k. Okay, now there is a one more pole added here, so 1 plus s by 10 here, and after that there is a one more pole is added here at here, so 1 plus s by 100 here. So like this you can write the transfer function here. Now I want to find the value of k here. So to find the value of k, I'll take the lower value here. Okay, lower value means at this particular point here we have a 4 dB. So I'll write here what I did is k by s. I'm taking this lower frequency region in dB is equal to 4 dB here. There's a magnitude at omega equal to, what is the frequency here? It's a 2 here. Omega equal to 2 here. Okay, right. So from this 20 log k minus 20 log, okay, w means s here, okay, w is equal to what? How much it is? It is a 4. Now log we need w is nothing but 2 here, so 20 log k minus 20 log 2 is equal to 4. Okay, we know that log 2 is nothing but 0.3. You should remember these values. Okay, so sir, I am preparing for a exam, the calculator is not allowed. How can you do these problems like this? No, you have to remember the small values of this log values, exponential values. Without knowing that values, you cannot crack AE examination, right? And that too, this paper, especially this examination, is having a gate syllabus. Okay, so that you have to focus the gate problems, and you have to focus on the gate problems, 2 marks problems also. Sometimes they will directly give the 2 marks question. Okay, they won't think that whether the candidate will solve this problem in the examination or not. So it's a competition, right? As I told you, everything is possible in competition, right? So 20 log k minus, so it is nothing but 6. Okay, if I send to the right side, you'll get is 10 here. So log k is nothing but 10 by 20. So k is nothing but square root of 10, which is nothing but 3.16 here. So 3.162 value, you get it here. What's the value of k here? Now substitute the value of k here in the transfer function. So 3.162, okay, and write a 2 plus s divided by 2 into s into 10 into 100 into 10 plus s 100 plus s. Okay, so then you have to write e into 10 into 100. Okay, so simplify this equation here, you'll get the answer. It has a, so let me correct here, so it is not that correct. So it's right. So 2 into s, I'll take this 10 out here. So 10 plus s divided by 10 here, and 100 plus s divided by 100. So if you simplify this, 3.162 divided by 2 into 10 into 100 divided by 10 plus s into 100 plus s here. Now solve, by solving this equation, you can set that the answer will be 1580 into 2 plus s divided by s into this value. So answer will be C is the right answer for this question here. So C will getting the C is the answer, right? So I'll move to the next question, right? And this is the last question that is asked in this paper here. The steady state error constants Kp, Kv, Ka of the following system are respectively. So there is a diagram given here: 10 divided by s into s plus 1 s plus 5, and the feedback loop having a 1 by s is here. Okay, now what is the Fourier transform function? So g of s into h of s is equal to 10 divided by s into s plus 1 into s plus 5. H of s value is 1 by s here. Okay, now first value of kp. So kp is nothing but limit s tends to 0 g of s into h of s. So if you're substituting in this equation here, so simply get 1 by 0 is nothing but infinity. Next, kv, limit s tends to 0 s into g of s into h of s. Substitute the value here. Okay, s gets cancelled, but we have 10 divided by s into s plus 1 to s plus 5 here. So this one also is going to be infinity. And next, ka is nothing but limit s tends to 0. Here we have s square. Now I'll explain. 10 divided by s into s plus 1 into s plus 5 into 1 by s here. S into s, s square, this gets cancelled, and substitute the value of s is equal to 0 here. 10 divided by 0 plus 1 into 0 plus 5 here. So it's going to be 2 here. So answer is infinity and 2. So C will be the right answer for this question. Thank you friends. Thanks for watching my videos. If you want more preparation videos, please subscribe to my channel and share with your friends, as your comments will make us motivation to do more for you. Okay. Thank you friends. Have a nice day. All the best for your examination preparation.